Hello, everybody. Thank you to be here. My name is Bortone. I know it's a difficult name if you're not an Italian as a speaker, but you get used to it. Today I want to present abusing Azure Arc from service principal exposed to reverse shell. I'm a penetration tester working at Mer Group. Mer Group is a pharmaceutical company, and I work in the offensive security team. We mainly do web application pen testing, Active Directory, and infrastructure. I also do some research in my free time, mainly Active Directory, Windows internal, and everything that is Windows undocumented. And you can find me on XYBytes on Twitter or LinkedIn. So, what is Azure Arc? Azure Arc is an Azure service that allows you to connect servers from your on-premises environment or internal infrastructure or other cloud platform to Azure itself. So you can control this server from the cloud, right? And you have different services there like monitoring, Azure Defense, Azure Sentinel, Azure Security Groups. You can also run commands through Azure Command Line tool. So if you want, you can simply connect back and run command. The way that this works under the hood is that you have an agent running on these servers, your internal infrastructure, and this agent connects back to Azure, and now you have a communication channel between these two, right? An example of this, you'll see here my own server is in my internal infrastructure, it's server 01. You can read the domain name, the fully qualified domain names. My domain is xybytes.com. And on the left side, you have a bunch of options like settings and other resources and features that you can use, right? The important thing to understand here is that to use Azure Arc, you need to have a service principal, right? Because the server needs to connect back to the cloud, so it needs to authenticate. So you need to create a service principal before you're able to join a new machine to the cloud. In my case, this is my service principal. It should be hybrid IRC. And of course, you need to create a secret, right? Don't try to use my secrets because it expired. But yeah, you need to create your own secrets. And after you do that, Microsoft suggests you 3 roles. There is the first one that is for onboarding. Then there is the second one for Kubernetes. And then there is another one for administrator's task, right? In my case, let's assume that we give to the user the first role and the last one, right? So we can onboard new machine and we can control Azure Arc. When you want to add the servers with Azure Arc, you have 3 options, right? You can add a single server, or for example, you can add multiply server. In our presentation, we are going to use the second one. So we add multiply servers to the cloud, right? This is used when you have more servers, your internal infrastructure, and you want to join them at the same time, right? You don't want to do one by one. So when you click that link, you are bring back to this page where you can select the deploy method that we can use. And in my case, we're going to use group policy, right? So we're going to create a GPO, and when this GPO is applied to the OU, then all the machines in that OU are going to start the onboarding phase and join the Azure Arc, right? And if you read here in the second point, Microsoft tells you that you have to create a remote share when you are going to load the Windows installer package. And this network share needs to be accessible by domain computers, admins, and domain controllers, okay? The third point that you need to follow is that there is a deploy toolkit that Microsoft provides that you need to run to deploy this technique, right? So if you see here, when you go to the link, you have this deploy toolkit. This is a zip file, and when you open it, you have mainly 3 scripts, 2 scripts and 1 PowerShell module. Deploy gpo.ps1, enable Azure Arc.ps1, and Azure Arc deployment.ps1, right? So you have these 3 scripts. The first script is a script that it needs to be run, executed in a domain controller, and makes the following actions. Is deploy the Azure Arc servers onboarding GPO in the local domain, so it's create the GPO. And it copies these other scripts, enable Azure Arc.ps1 into the shares. And as you can see here, what we do, we pass two parameters, the service principal ID and the service principal secret. And also we pass other information like my domain, in this case, xyby.com. The report server qualified domain name is the server where you have the share. And also you pass the network share, in my case, Arc onboard share, and other information like the subscription ID, the tenant ID, okay? And what it does, these scripts create a GPO, right? In fact, when you run this script, then you can check and you see that there is a new GPO that is created in the network. It usually has this syntax, and you can find it quite easily. The other script is enable Azure Arc.ps1, and is the script that is basically is going to be executed by the server, and is going to do a bunch of check in the beginning, check if the machine is an Azure VM or is a non-Azure VM. You check the framework version, the PowerShell version, and then is going to install the agent on the machine, and is going to connect the server to Azure Arc. And to do that, is going to use the service principal, right? Because it needs to authenticate to the cloud. And the last script is a module, and is basically a wrapper for DB API NG. I'm going to explain why it's there and what it's used for. So when I was studying all of this, my question was, okay, where is the secret stored and how is protected? Because the server needs to take the secret somehow, right? Because it needs to authenticate. So where is this secret? This secret is in the file that was copied during the deploy GPO scripts was running, and is in this file, and you can find this in the network share that we previously created to load the Windows installer package. But the problem is that if you're going to see in the file, inside this file, the secret is encrypted, right? So if you try to open it or read it, it's encrypted. So how this is encrypted? Is encrypted using a Microsoft technology called DPAPI-NG. So how many of you knows DPAPI? Okay, it's enough. Okay, so DPAPI-NG is the evolution of DPAPI. It was introduced by Microsoft in 2008, 2012, if I'm not wrong. And it basically allow you to encrypt a secret using a user or a computer account, and this secret to be decrypted by another user or another computer account in your AD environments, right? So for example, you are in Active Directory, user Chris, and you want your secret to be decrypted only by user Phil, okay? So in this case, you can use this technology to use a seed as a descriptor, let's call it protector, and only that specific seed can decrypt your secret, okay? It can be a group or it can be another user, right? Another object in AD, generally speaking. The condition is you need to be inside the domain, because you need to be able to contact the domain controller, because with the domain controller you get the key that is necessary to decrypt the secret, okay? Otherwise you cannot do it. It's not like DPAPI. So for example, this is the function, the Windows API call that is used to encrypt the secret. And as you see, there is the first line here, the descriptor. This is basically the seed, right? So it's the seed that you need to specify when you want to say, okay, I want this secret to be decrypted by this specific seed, right? So it's a seed protected blob. You don't need to know a lot about DPAPI to exploit this vulnerability that I'm going to show here. But if you want to dive deep into this, take a look to this presentation. It was done in 2017 at the Black Hat. So she will dive deep much more than I can do on this technology, how it works under the hood, right? So why I explained DPAPI-NG? Because if you're going to look into the scripts I showed you before, deploy GPO.ps1, you're going to find this line of code. And you can read by yourself the comments. Encrypted the service principal to be decrypted only by the domain controllers and the domain computer security groups. So if you see, there is this function protected base 64, and this means that the secret here is the secret principal secret, is the service principal secret, is going to be encrypted using the descriptor, right? Here, you see the first parameters. And this descriptor is composed with the domain computer seed and domain controller seed. So you can already see the problem, I believe, because right now, with this configuration, any computer accounts in your domain can decrypt the secret, right? Because this is the seed that was used as a descriptor. This is the Microsoft-based configuration. You can change it, of course. You can use another seed if you want. But if you don't do it, this is what you get. You get a secret that is encrypted and can be decrypted by any computer account in your domain. And if you're going to see in the other script, the enable Azure Arc, that is the script that is going to be run by the machine, what it does is use the opposite function. This is unencrypted base64, and it is going to decrypt the secret, and it can do it because it's the computer account, right? So let's exploit it. Let's try to use this feature to gain the service principal. So we have the scenario is this, right? We have successfully penetrated the internal network. We have a user account, in this case Chris, in Active Directory, and we identify the network share containing Azure Arc deploy directory, right? When there is the secrets. So the first thing that we can do, there are different ways how you can get machine accounts in Active Directory, right? You can compromise computers, or easily you can create a machine account with machine account bots. Okay, these are well-known misconfigurations. If you do penetration testing, you will find this quite easily in many clients' infrastructure. And in my case, this user can create 10 machine accounts, right? So a normal user in your AD can create a machine account. So what I did was, you can import PowerMed, right? This is a tool that is used to create machine accounts, and you create a fake 01 computers, and you impose your own, you set up your own password. In my case is 123456, and now you have a machine accounts in your AD environments. Now that you have your machine account, you have to authenticate with it, right? You can use run as with net-only flag, probably is the easiest way. Or you can simply do pass the ticket, so you can use Rubius to authenticate like this machine account. As you can see here, there is the user, fake01, is the hash, and I do pass the ticket. So now the TGT is in memory, and so we are authenticated as fake01. Because, as I explained, the secret is encrypted with computer account as seed, now we can simply use the same script that I showed you before, the same functionality, the same function like unprotected base64. We can grab the secret, and as you can see, because we have the computer account TGT in memory, the fake01, we can decrypt the secret and take the value there, right? So this is one way to do it. Of course, there are other tools that you can use. This is one of them. It's called Secret Management, DPAPI, NG. It does the same things, right? You use the function, in this case, convert from DPAPI NG secrets. You get the encrypted secret, and you get the plain text value, right? So basically, we start from a normal domain user, and now we were able to escalate to the cloud, so because we have a service principal secrets. What about the rest of the information, right? The rest of the information can be found in arcinfo.json. This file is in the same shared folder where you find the secrets. And inside this file, there are the other information that you need to connect to the cloud, right? The tenant ID, the resource group, the subscription ID, the service principal client ID, right? Now that you have all of this together with the service principal, you can simply use the Azure command line tool. You can log in with the service principal, right? And because the service principal has admin roles, you can enumerate all machines that are there, and you can also run commands. In this case, what I did was to run a base64 reverse shell, right? And I got the shell on the server. And the interesting part here is that you are system, right? So basically, from the internal infrastructure, I moved to the cloud, and now from the cloud, I move back to the servers, because now I can compromise everything that is there, everything that is connected to Azure Arc, right? So let me show you a video POC before we move on. Can you see it? Right. No. So this is my user, Chris. It doesn't have any special privilege. It's a normal AD user account. So let's check the domain. This is my domain. Now, the next things we want to do, we want to check the network share. In this case, the network share is accessible to everybody because I wanted to show you that this secret cannot be decrypted by a normal user, but normally this network share should be accessible by computer accounts. So we have the two files. The first file, arcinfo.json, contains the rest of the information we need to connect to Azure. And then we have the encrypted service principal secret file that is encrypted, right? So we cannot read it with this user. So let's try to decrypt, see if user Chris can read these secrets. So we're going to use the module that I showed you before. And we get error, right? Because we are a normal domain user. So now what we have to do, we have to get a computer account, right? So let's see if we can create a computer account, right? So let's see if machine account quote is there and we can exploit it, right? This is one of the many ways you can do it, of course. If you can get a computer account in other ways, it's the same things. It doesn't matter. This case is equal 10, so we can do it. So we are going to import PowerMed. Not PowerCut. Right? Now we can create our computer account. I think fake01 already exists, so let's create fake03. So now it's going to check if this computer account was created correctly. And it's there, it's in the domain. So now what we have to do, we need to authenticate as this machine account, right? So we use Rubius, our favorite tool, with the password that we know, because we just created it. And we ask for a TGT. And now we have the ticket, right? And it's in memory. So now let's try again to decrypt the secret. And now it should be possible to do it, because this TGT is in memory. Same command like before, and now the secret is there. Right? So now we have the secret, we have the other informations. There is also these methods that you can use to decrypt the secret if you want. And the result is the same, right? The TGT is still there. So now we can authenticate to the cloud, right? We are authenticated. and we can move laterally, right? We can start enumerate what is there. We see that there is a server 01 disconnected to Azure Arc, right? So now let's try to get a reverse shell from there. Of course, we have to run a listener with netcat. Right. And now we're going to use Azure command line tool with command run command. And then this is the basic C4 reverse shell, right? It can take a while because the agent needs to connect back to Azure. So sometimes it doesn't work so smoothly. And then you get the reverse shell, right? So let's go back here. Okay, so the conclusion, very briefly. So this is represent a new vector, attack vector that hackers can exploit to move from on-premises environments to the cloud, and to the cloud back to on-premises, right? It's important, in my opinion, to always review Microsoft scripts. Okay, so don't use the default configuration. Always read what you're running before you're running, right? Because sometimes you have these configurations that are too broadly. In this case, one thing you can do to avoid this problem in your infrastructure is to create a subgroup of machines, right, that you want to onboard to Azure Arc, and use this seed of the seed of this group as a protector, as a descriptor, right? In this way, you can at least limit the attack surface, because right now with this configuration, any computer accounts can decrypt the secret. But if you create a subgroup of machine and you use this seed as a descriptor, in this case, the attacker needs to compromise one of these machines to move laterally, because any computer account wouldn't work in this case, right? So this is the first suggestion. Create a subgroup of machines. The second suggestion is be careful with the roles and the permission you give to the service principal, right? In this case, I gave administrator permissions, and that's why I was able to do this game. Otherwise, it would be impossible. So use always the less permission as possible you can give to the users, right? So it's not a bulletproof system, this one, because if you create a subgroup of machines, the attacker can still violate one of these and move laterally, but at least the attack surface is, and the impact is limited. Okay? And so, do you have any question for me? Yes.
How would you force, I know it's deployment through policy, but how would you force an administrator to do the deployment by forcing MFA? Therefore, you wouldn't get to the point whereby somebody's doing the deployment.
During the deployment, this is done with the GPO. So usually the administrator is going to apply the GPO to the machine that he wants to onboard, right? And when the GPO is there is also the network share somewhere. So the point is, when the attacker can identify this network share, it can take the secrets, right? So you can try to limit access to the network shares, but if you do it, then the computer account cannot get the secrets anymore. So this is the game, and the problem is to limit the number of machines who can access this secret. Probably, this is the solution.
Or not allow that to log in.
Yes, or block the login. Yeah, but if you block the logins, then the machine itself cannot onboard anymore. So what you can do is you can give one specific permission to the service principal, like the onboarding permission. So the only thing that they can do is onboard new machine. So you cannot run commands, right? So you should do it for sure if you can. I don't know if you can do it. Probably this could be another things. Yeah, but the service principal is necessary because the deploy GPO needs that service principal and it needs to connect to Azure. So you need to pass this information somehow. It could be much more useful to limit the things that the service principal can do, right? So limited the permission as possible, and just onboarding, it should be fine, right?
Do you consider restricting standard users from being able to create machine objects and mitigation?
Yeah, for sure, machine account quotes doesn't need to be there. Okay, this is a misconfiguration that you always report when you find during pen testing. Okay, because it's very easy to do it. The problem is that AD environments has many misconfigurations, from for weak ACL to any other things, weak certificate, right? So when you are there getting a machine account, I don't want to say that it is always easy, but it's always possible most of the time, right? So you have some vulnerable ACL or some weak password or some other problems with policy and you get a machine account, okay? Or you have maybe an exploit, right? You have an exploit, you can do RC into the servers, you get local administrator, bam, you have a machine account. You dump from memory, Mimikatz, and you have a machine account. So yeah, it's very difficult to avoid, to protect machine accounts, right? It's a little bit easier with users, but with machine accounts, it's complicated. Okay.